Hello everyone, I am Manglesh Kumar Gupta and today I will be demonstrating how to simulate flow past a diamond shaped body using OpenFOAM. OpenFOAM is a powerful open source computational fluid dynamics software. It's widely used for uh, simulating fluid flow problems, solving heat transfer problems and much more. Now in this slide the domain is defined for external flow and a 2D body with a diamond shaped using OpenFOAM source. So now this slide describes what we will demonstrating to for diamond shaped body. So this is an external flow problem. So the external flow problem, now domain is rectangular shape, rectangular shape 15 unit in x direction and 10 unit in y direction. Now the obstacle is diamond shaped, which has major axis is 2 unit and minor axis is 1 unit. So in the actual domain, the minor axis is along the flow direction, and the center of the diamond is at 2 unit in x direction and 5 unit in y direction. The government differential equations that we are using in this flow problem, which is continuity equation and Navier-Stokes equation for incompressible flows, and a solver that we will use for our simulation problem, that is ICOFOAM, which is specifically designed for incompressible laminar flow problems for simulation, and the boundary conditions that are in this problem, that is velocity inlet and walls are no slip walls are at no slip condition, and the pressure outlet condition. And this is an schematic diagram of 2D model description of our flow problem, in which location of the diamond shaped obstacle is showing in this figure, and the inlet and outlet pressure conditions are showing, and walls are at no slip conditions. The domain dimension is 15 units in x direction and 10 units in y direction. Now after defining our problem, we are going to OpenFOAM terminal. So for our problem we are using Oracle VirtualBox, that is for our institute's VirtualBox. And now let's create a directory for our problem, that is ls now, and pwd. Okay, so to make a directory, the mdr dir and OpenFOAM, let's name it 123, and let's name assignment 123. Okay, assignment 123. Now there is something problem not found, but can be installed with okay. So there is the problem in code, that is for making directory. This is mkdir OpenFOAM assignment 123. Now the directory is created. Now open the directory, the cd OpenFOAM assignment 123. Okay, we are in the directory of OpenFOAM assignment 123. Now create a directory for geometry, that is mkdir geometry let's okay, then open CD geometry. Okay, now LL. Okay, so for creating our flow domain, we are using GMesh software for our domain creation, that is GMesh MSH, and let's name the GMesh file, that is diamond dot geo. Let's enter. So now GMesh software is now open. So let's create our domain and GMesh software and mesh it. Create a mesh. Let's start geometry, elementary entities, then add. First defining the points for our domain. So initial point, first initial point, let's create 0 0 at. So now you can find there 0 0 point is located. Now for in x direction is 15 and y direction is is 15 and in y direction is 0. At let me create a point in x direction is 15, in 15, and in y direction is 10, and in x direction is 0, y direction is 10. Now all 4 points for our flow domain is defined, and then create a line passing through these points. Let's click here, then click the end point, then again click on the point and then click here, then again by clicking points one by one the line will be created. Okay, then again take a point command and define diamond points. By defining a diamond, take a center point, like the center of the our diamond obstacle is at 2 in x direction and 5 in y direction, then add it. You can see there is the point, that is 2, 5. So we are defining the 4 points for our diamond. So first in x direction our minor axis is there, so minor axis is 1 unit, and in y direction our diamond's major axis is 2 dimension. Now in x direction, so 1.5 in x direction, and in y direction is 5. Now this is the point again, and 2.5 in x direction and y direction also 5. Okay, then define a points in y direction. So y direction is 2 unit, so 1 unit in upper direction and 1 unit in lower direction of center point. So now in upper direction is 2 in x, and in y direction is 6 unit at points. Now in x direction is 4 unit, in x is 2, and and in y direction is define 4. So this is the point. Now create a line, join these points to create a diamond shaped body. Let's click one by one every point and join them. Okay, now our domain is created. For creating a surface, let's create a plane surface and select outer domain, then our obstacle, which is diamond shaped, and then E for end selection. Now our plane surface is created, and then extrude it in Z direction for 1 unit, and mesh layer is 1. Now select a surface and E for end selection. Now let's check the body is created in 2D. Okay. Now after that, let's create meshing. So meshing is 1D, 2D. This is 2D meshing, and this is now 3D meshing. So we need to analyze near the diamond shaped body what is the flow situations may arise. So to refine more to get more accurate results, we need to refine meshing near the diamond shaped obstacle. To do this, go to edit script and these are our points for obstacle 0.1. Let's change the restrictions length of these points, that's 0.1, then again 0.1, 0.1. Okay, let's save it, Control S and then cut, and again reload script. Now we can again generating. Now let's see the meshing near the diamond part is more refined for our flow problem. Now then, in physical groups we need to define surfaces and volumes. For defining surfaces, inlet, outlet, top, bottom and front and back, and then volume. So first inlet, the inlet body is in this, inlet surface is in this direction. It's U for undo. Okay, so you can see that this is our inlet, and E for end selection. Now then outlet, then this is our outlet. Okay, you can see that, and E for end selection, and then top and bottom of top and bottom surface. Top is this, E for end selection, and bottom. Okay, E for end selection. Now front and back surfaces, front, back surfaces. This is our front surface and this is our back surface. Now E for end selection, and then define surface for our diamond shaped optical. Okay, so diamond, let's name it diamond, and select all the surfaces of our diamond shaped body. Okay, now all surfaces is selected, and E for end. Let's check it in manuscript script to ensure that all parts of then physical surfaces are here: inlet, outlet, top, bottom, front, back, and diamond. Let's name it diamond. Okay, then again save and reload it. for updatation now. Okay, let's again, and then one thing is volume. Let's name it volume. For defining volume, let's choose this center bar. So complete volume will be selected, and then E for end selection. Let's check again for in script the volume is created. Now there is available volume now. Okay, after that let's again see the meshing. View for undo. Okay, now our meshing is completed. So for open form simulation we need a special type of file extension, that is .msh, and name it diamond and save it. The version is version 2 ASCII. Okay, let's close it and open the our terminal.